Okay, folks, so at the end of performing your research, when you feel like you have a nice, clean story to present to the world, you submit it to a peer-reviewed journal. Peer-reviewed journals have usually one primary editor, but also many other editors. And so what they do is they look at the papers being sent in and they do kind of a first pass. Does this research that was sent in match the purpose of our journal? And if it seems like the research is a good fit, the editor will pass your paper on to the peer reviewers. Peer reviewers are peers in the field, but generally they are experts. And ideally, these peer reviewers should understand what you are writing about at a very, very deep level. You want them to have a critical eye to kind of make sure that you are doing this research in a way that is ethical, that is correct. Is your research design appropriate, right? So we got to make sure that we have peer reviewers to kind of check us before we submit our paper for publication. This makes sure, or more often than not makes sure, that the science that is being published is real and is repeatable. So, to wrap up, folks, what does this preclinical drug development look like in reality? Well, as a graduate student in a lab, I actually joined a lab right during the process of preclinical drug development. So I saw much of this happening as I was on my way to get a PhD. What can happen is 10 to 30,000 drugs or so are put through some kind of screen to ask, does this drug work? For example, does this drug kill cancer cells? And out of those tens of thousands of drugs, you'll get maybe 100, 200 hits. Oh, these drugs seem to work a little bit. Now, depending on what type of research you're doing, you might not just want a drug that kills everything, right? Maybe I am doing breast cancer research. I want my drugs to kill breast cancer, but not just to kill everything in sight. I want it to kind of be specific. So I'll do more experiments to help me narrow down from that now 100, 200 or so, to some that are not just killing everything, but killing what I want them to kill. And I'll usually end up with 1 to 5 drugs or so that seem to work well, that seem to be specific and only doing what I want them to do. And also, it's usually nice to have a drug that's a bit interesting or maybe works in a new way, so we're not just making the same drugs that we already have. So from there, we'll hopefully be able to narrow down from tens of thousands of drugs to one single lead compound. Now, once we've narrowed it down to one, usually we need to figure out how it works. So there may be years of study for the single drug to determine how it works. How is this drug killing cancer cells? What is it doing inside of cells so that they ultimately die? And that is what the process of preclinical drug development looks like. It can take this part maybe 5 to 10 years alone before a drug makes its way from a screen to what is up next, clinical trials. So that wraps up our discussion of preclinical drug development. This is largely happening in labs at universities and colleges, performed by undergraduate students like you, graduate students, and postdoctoral scholars. We learned a little bit about research as well. It follows a scientific method, it's supposed to be rigorous, and we need to be fact-checked by peer reviewers to make sure what we're publishing is real. The preclinical drug development happens in stages. I showed you a little bit of how we got from tens of thousands of drugs down to just one. And with that, I leave you with this. Cat meme. See you in class.